Hi, it's my pleasure to introduce Callum Macmillan. He's the co-founder of Dimension Studio, and he's going to be doing a talk on real-time engine-driven virtual production, specifically in focus of the work they've been doing with LED light stages, and also with volumetric reconstruction of extras and how they can be integrated dynamically in real time into productions to enable directors and producers. So could you please welcome Callum Macmillan?
Thank you, Nigel. Thanks for having me today. Yes, I'm going to do a presentation. I know it's 15 minutes, so it's going to go in the blink of an eye. I'm going to give a quick overview of what Dimension does and then talk a little more about how what we do relates to virtual production. So I'm going to keep it very high level, Nigel. I'm just going to go and share my screen. Give me a shout when you can see it. You got it? Excellent.
Yeah.
Off we go. So yeah, my name's Callum Macmillan, and I am one of the co-founders at Dimension. And Dimension is a studio that specializes in state-of-the-art volumetric capture and real-time production. We have a suite of next-generation studios for making this type of content. And I've been working in the industry for about 20 years now. My background is in multi-camera and multi-view imaging and volumetric capture. And I've been lucky enough to work across a range of different mediums, from film production, filmed entertainment, broadcast, and immersive content like VR and AR. Dimension was launched about 3 years ago with the intention of creating high-end cinematic content, but as I say, for lots of different platforms, not just for filmed entertainment. And over the last 3 years, we've been quite successful at what we've done. The studios have grown over the last 3 years as well. We started in London, and now we have studios in Gateshead, partnership in Washington with Avatar Dimension, one with 86 Slough, which is an XR stage, and one with Nikon and Mark Roberts with Polymotion. All of these stages help us generate this next generation content, both in terms of LED warm and volumetric capture. The London stage was the first one in the world to launch Microsoft's mixed reality volumetric capture technology outside Microsoft itself. And these mobile stages have been built with Nikon in continuation of that technology. What you can see at the bottom with the Polymotion truck combines 3 different technologies. We've got volumetric capture in there, we've got motion capture, which is markerless for skeleton tracking, and we have marker-based tracking for rigid body. So you can see on this example, the tennis player that we're going to have in the scene has a tennis racket, and the rigid body tracking will enable us to track the tennis player. The markerless mocap will get the skeleton, and then the other camera system will get the full surface reconstruction. There's the control panel. So there's the surface reconstruction, skeleton, and rigid body. Bringing those 3 things together creates an asset. Like, I'll just click on this. So hopefully I'm going to click this and you'll be able to see what it looks like in real time. This might just take a second to load. There we go. And if I take this link, hopefully you guys might be able to see this too. If I go back to our chat, where do we post stuff? Nigel, do you know if there's a chat available?
Sorry, I was muted. Yeah, if you link it to the chat here, I'll put it in the chat or Discord. It's perfect.
There you go. I've just pasted it. So yeah, if anyone wants to have a look, hopefully that URL opens you up to this capture, but this is one of the ones that's done on the Polymotion truck to give you an idea of the type of output we can get from these studios. Okay, just got to jump back into the pres. Great. So yeah, just trying to link it a little bit more to virtual production now. Because we have a background in optical capture and cameras plus real-time production, I guess our three key pillars are creating the photoreal environments that can go into real-time production, so the photogrammetry and real-time CGI, live characters, whether that's streaming limb data to drive an avatar, or as we've just shown, doing a volumetric capture, and then also the remote collaboration, which particularly in the time of COVID has been critical to allow people to work on these projects and collaborate remotely at all stages of the production process. Also, it's probably worth saying that virtual production can mean many things depending on the context. So for me, through my lens, I kind of see 6 different areas of virtual production. We have camera, so that's the virtual cameras like Simulcam and VCam. We've got the LED walls, which is the in-vision for final pixel, so behind the talent, and outer vision for lighting. XR, that's a very specific type of virtual production studio for live recordings and broadcast and live events. The visors, pitch viz, previs, tech viz, all of that visualization work that happens prior to principal photography. VAD is the snappily named acronym for Virtual Art Department, or what we would have called a real-time production team before virtual production came along. But that's the team that does the worlds, the scenes, the character, and the humans if they're needed. And then lastly, volume. Everything's about a volume, the LED volume, so volumetric capture, motion capture, performance capture, tracking. These are the kind of areas that I see as kind of production streams, if you like, the component parts that make up virtual production. Just digging into that a little bit, these are just some quick GIF animations that show some of the work in progress that we've done on previous projects. This is an example of previs where we're working through the layout of a scene. You can see how easy it is to iterate in a real-time engine and adjust all the component parts, including the atmosphere and the objects. Key learning for us is making sure that all the controls that we need are exposed on any asset. You never know what a director is going to ask for at any point in the production process, and the quicker you can iterate on it and control that asset, the better. In terms of the camera, again, what we see here is how you can frame up the images and get a sense of the composition very, very quickly. Just move on to here. Okay, and then just looking at camera a little bit. So Simulcam is basically the overlay of a virtual world or character into a live action feed. So that's to help with live action camera framing and composition. VCam here is the window into the virtual world. This is used for camera blocking and creative design prior to principal photography. The VAD that we have, the acronym of Virtual Art Department, as I say, this is the team that puts the worlds together, the scenes, the characters, and the humans. And the amazing thing about the Virtual Art Department is that if the remit is there, what is done in previs can be developed and polished and refined all the way through within the same ecosystem and the same pipeline to be good enough for final pixel, i.e. it's good enough to sit on an LED wall and be used in vision for principal photography. So that just shows the capability of the virtual production pipeline. This is an example of another Virtual Art Department test that the team did, Space Opera. This was combining a volumetric capture with a virtual world and virtual camera moves to just get a sense of how these things could interplay. And all of this was done in a real-time engine. So that's obviously not done on an LED wall, but it is a component of virtual production in that it was a real-time engine, a volumetric capture, so virtual scene and virtual character. Moving on to actual LED wall production. This is a test that we did back in the summer with some very top-end partners from DNEG and 86. These are our partners and ARRI that helped us create this test. But this was an LED wall test where we used high-density dot pitch LED for the Envision images behind the character, and other LED walls that we could fly out of vision for reflections and light wrap. This was an early test. Right now, we've got plenty of other productions that we're heads down in pre-production for to do this kind of filming. And the results here are a combination of the LED wall plus in-engine for wide shots. So one of the things that this highlighted to us was the need for believable digital extras in virtual production. So Dimension built the virtual environments, the 3D photorealistic environments that went on the LED wall, and they're fantastic to work with for virtual production. The next iteration of this is to get just as much believability into the characters that you would put on the wall. We'll come on to that a bit later on. But that was a key learning for us. That's an area that we've got to work on and develop. Just touching on XR quickly. XR is like I said, a particular type of LED stage that's tailored for rapid live events and broadcast. It's very popular for sports broadcasting. And this is one, again, that we've put together with 86, and I just want to run through the component parts of it. So you have the volume. On the floor here, you can see a few reflective markers. That's for a MOSIS marker-based camera tracking system to link the live action camera to the virtual camera. We have the floor, the walls in the top right-hand corner of the picture-in-picture. You can see the robot. That was another way of tracking the camera. We had the camera on a bolt from Mark Roberts Motion Control and sending the data via 3D into engine. And then on the walls themselves, you have the perspective corrected content. So that's correct from the viewpoint of the live action camera. And then we do the set extension around the LEDs themselves. And that is both a background plate and foreground AR plate that you can see of the footballer there. And hence the name for XR stage, for extended reality. This was put to good use recently in Eurosport. This is another stage that we built, and this has won some awards recently. And I'll just play this quickly so you can see that.
We have Karolina Pliskova now right here next to me. Karolina, congratulations. And there she is. Technology makes it happen, which is unbelievable.
They do and try and do a high five later, but it doesn't work very well, so I'll skip over that. But that gives you the idea of XR Studios, and very versatile, very compact LED stage, doesn't need a lot of space, but can be made to have a very large field due to the set extension.
We have Karolina Pliskova now.
Just going back to digital humans now and volumetric capture, I just want to use this video clip to compare and contrast where we've got to, basically. Sticking with sports broadcasting, this is for Sky Sports, and it's a promo that was shot 20 years ago. I was lucky enough to work on it at the start of my career, and it uses multi-camera array to basically try and show the concept of where they think sports broadcasting would go.
Imagine what advances in technology the new millennium will bring. Imagine how these advances will enhance the TV coverage of sport. Right now, vigorous testing is underway, which will take sports coverage to a new and wonderful dimension. And although no one knows how far boundaries can be pushed, one thing is certain. No one plans to do more than the broadcaster which has already pioneered live interactive TV sports coverage, where you call the shots. Sky Sports, on Sky Digital, the sports broadcaster for the new millennium.
And fast forward 20 years, and here we are with Sky Sports at the Open in Portrush. That white dome you can see in the background is our volumetric capture stage. And this was so many firsts in this. This was our deployment in 2019 of the volumetric capture, brand new volumetric capture solution we built with Mark Roberts, the Polymotion stage. And this was its first outing. We, again, combined motion capture to track the rigid body or bending body of the golf clubs, volumetric capture to get the golfers, and we had to deploy cloud compute for the first time to allow us to process the assets quick enough to meet the production schedule of the broadcaster. And then finally, everything is playing in a real-time engine, tracked in and played back via VizRT, I think, linked to Unreal Engine in the studio at Portrush. And this had really powerful editorial value. It wasn't just the wow factor of the technology itself, but the presenters were able to analyze golf swings and provide commentary that you couldn't possibly do normally because you couldn't see the action with the naked eye or study it in the same way as you can with a virtual human. So concept to reality, Sky Millennium to Sky Scope, that was 20 years. I think the iterations of the technology that we're seeing now are going to move a bit quicker than that, particularly the things that we're seeing at CVMP this year are a great example of how quickly the technology is evolving. From our side, what do we see as the future? Well, as I said, I think volumetric extras for final pixel is a key requirement, and also all the enhancements being done with neural networks and neural rendering to allow us to make this content in more robust and effective ways. This is just a quick example of some of the work we're looking at around volumetric extras for crowds. So we are looking at things like fidelity, how do we get better color resolution in our shots, the variance across the surface, so surface segmentation, seeding and distribution across a volume, how does that work in real time versus offline, and things like surface normals for relighting. So we need to get coherence across our captures for the purposes of relighting. And just very quickly, one more thing is motion blur. We've been looking at things like object-based motion blur. When we have our captures, the topology doesn't always stay consistent. So if we want to generate things like motion vectors for motion blur, we are looking at ways for how we work over the limitations, the inherent limitations in the mesh data. And just to sum it up, really, so thinking about virtual production, as I said, there's these kind of 6 key areas in my mind that work as production streams, and really at the core, at the heart of virtual production, there is real time. That's both in the engines that can play this content and help us iterate and develop, and also in the collaboration. That's key. And the idea here is that across many different departments in the production process, this should reduce iteration time and drive cost down, creativity up. That's the objective. Thank you.
Thanks so much for your talk, Callum. I thought the compositions you've done with virtual production are absolutely breathtaking. I can't wait to see how the reconstruction progresses, especially with the relighting, and to improve those compositions for real virtual or virtual on real worlds. I do have, we don't have very much time for questions, but we'll try to just do one quick one. And it's actually on the aspect of view-dependent rendering and for the LED light stage and the motion tracking technology that's required for the camera position. And I was wondering
Yes.
what you investigated.
Yeah, so in terms of camera tracking for LED stages, the whole technology field is evolving rapidly. It kind of we've tested a lot, and it breaks down into marker-based tracking, SLAM-based tracking. There's optical tracking, so things like OptiTrack, Viacom, marker-based tracking like NCAM and MOSIS. And then there's new technologies coming out. So again, at different price points, you've got I think it's EasyTrack, which is 5 trackers with new firmware on them that basically reduce the latency in the tracking. So I think EasyTrack have loaded their own firmware on, and instead of going into Engine, particularly in UE4 via Live Link, they've got their own plugin, which is the best way to reduce the latency. Another one that's doing a similar thing but isn't optical is Race Logic. So they are a company that specializes in ultra wideband radio, and Race Logic's system again will have its own plugin to go into engines and hopefully have a latency. I think they're targeting of perhaps down at 20 milliseconds if they can get there. I think currently it's around 100 milliseconds.
Oh, that's actually quite incredible to be that low in terms of latency. Thank you so much for your talk. It was very interesting. Unfortunately, we don't have any more time for any follow-up questions, but I'll try to get Callum to, I'll ask them after the talk and try to feed them into the Discord channel that have just popped up. All right, thanks again, Callum. That was a wonderful presentation. And now we're going to move on to a presentation from HaZ Dulull. It's my pleasure to introduce HaZ. He started his career in visual effects for film and TV, and he's actually transitioned in directing and producing, mainly because of the way real-time engines are providing the capabilities for virtual production. And he had an initial breakout film called The Beyond. And since then, he has had an array of films that have been produced under the studio that he co-founded called HaZ Films. And HaZ is going to be talking about pivoting his career into animation using specifically the Unreal Engine. Thanks, HaZ. Please go ahead.
Hi everyone, I'm HaZ Dulull and I'm a filmmaker.
I said stay live.
This is life.
And this unprecedented mix of human consciousness and technology.
I would suggest that this is the beginning of the future, of astronauts to come.
I see it! Excuse me, truck! Over there, go! Coming through! On your left! Ah! Now on your right! Fuck off!
As a filmmaker, I've always loved pushing the boundaries when telling high concept genre stories. Therefore, being a hands-on director with a solid grasp of this technology actually allows me to create a space for my collaborators and the actors to really live and breathe the worlds that I actually love building to tell these stories. So how did I fall into the world of directing CG animation? Well, it actually all started early this year when a comic book company reached out to me to ask me to direct and produce a proof of concept. And this project was called The Theory, and I picked a story called Battlesuit. And Battlesuit is essentially a CG animated proof of concept, essentially a pilot, in order to be made into a television series. And that was my first time, me and my team, really diving into creating CG animation using the Unreal Engine. So here's a clip of Battlesuit.
I could spend my entire career analyzing just one planet, looking at one species, without ever knowing for sure if I got their history right.
I'm out! Watch your back! My leg! My leg!
So Battlesuits came out on May 2020 and it was widely received in all the press, which was really cool. It was also part of a huge Made in Blade campaign from Razer, mainly because the entire animation that you saw was created entirely on a Razer Studio 15 laptop, which is powered by a Quadro 5000 RTX card. And it was all done here in this room. And it was quite groundbreaking because, you know, it was just a small team of like 3 people, including myself, that put that all together. So we were now in a position where we had doors open for us, and especially for me as a filmmaker, to actually dive into directing and producing animated films. And very soon we started to look for our next project, Mutant Year Zero, which is a CG animated feature film in production, which is what I'm here today talking to you about. Now, this production was done during the lockdown, as for obvious reasons for COVID, we've all had to work from home. So pretty much most of the film was actually put together here in my humble home and studio in London. So firstly, check out 60 seconds of Mutant Year Zero.
The Ark is humanity's last outpost, with the guidance of our leader, the Elder. He relies on stalkers, adventurers who leave the Ark, explore the zone, and scavenge for precious resources. Stalkers have to be more than human. That's me, Mr. More Than Human, aka a mutant. Our mission, he says, is a man, and that man is Hammond.
Sign us up for a suicide mission, Mr. Elder. This is insane.
The fate of the Ark depends on it.
You get to die. I have to live for all eternity. Oh, fantastic. Yeah! Seriously?
Okay, so that was super fun to work on, and we all had a blast making that early footage of Mutant Year Zero. When we started this project, version 4.25 of Unreal Engine was released, and there was a ton of new features in there. Plus, also, I upgraded to using an NVIDIA Quadro RTX 6000 graphics card inside an eGPU chassis unit, as opposed to what we did on Battlesuit, which was I used a Quadro RTX 5000 in my laptop. Hence the speed with everything on lit mode. That allowed us to create even bigger and complex sets with lots of effects and animated characters and assets live in real time, whilst I was able to explore around the environments to find my shots. As you can see, I'm still using the same technique with motion mixing animation in the sequencer just to get the performance I want with the characters. Now, action's a big trademark of mine in all of my projects, and Mutant Year Zero is going to push action much further. I wanted to take that single one camera take concept, you know, the ones that you see in movies like Gravity or 1917, and push it to some insane heights to elevate the edge of the seat thrills. Now, this particular camera move was actually a last minute thought I had when I was moving the camera around to frame up the action. I think I must have accidentally keyframed one of the positions too low on the ground, so when I was scrubbing back and forth, I noticed it and thought, actually, that's a cool shot. So again, thanks to the power of real time, I'm able to find these accident moments and just turn them into cool ideas. Then to really push it, I timed each vehicle action like a dance, so the choreography was all managed inside Unreal Engine Sequencer, and the action shot became this 570 frame single take action, where I was able to tweak each element on the fly, from the car spinning to the spaceship zipping by to the characters, sliding across the road to the explosions. I was doing all of this as I was scrubbing through the scene, again not waiting for any processing or rendering to be done. In this project, I utilized ray tracing not just to create a cool cinematic look, but also for direction and story purposes. So let's look at this real-time shot, for example. You can see that I'm using it to reveal the aftermath of a chaos that's just happened as we move across the street towards the water puddle, just to build up anticipation with a reveal via reflection, before panning up to ultimately show the audience there's literally hundreds of these killer drones. One of the things we did in this project, in order to push it to another level with quality and production value, was adding real physics to the objects. So things like wind causing a newspaper page to move as we provide plot points to the story for the audience makes the scene feel more alive. The same thing with the character's cloak, which creates this sense of mystery about him, but also elevates the cinematic nature of the scene. It's one of those things, like if you don't have the physics cloak, then the scene feels a little flat and dead. But with this, it feels right and kind of provides this high-level nature to the animation. We knew we had to take our human character side of things to another level when you compare it to the last project Battlesuit. So for the creation of the character Selma, we turned to Reallusion Software Character Creator 3 and iClone to build the character, rig it, and animate it before integrating it directly into the Unreal Engine scenes, where I could then just take it further with the animation. You know, the most impressive thing about the Reallusion character workflow is that it's extremely fast to prototype your character concepts with high quality results, utilizing the digital human skin and eye shaders, and along with dynamic hair and clothes. And, you know, for someone like me that isn't very technical or had the ability to actually create human characters from scratch, this is a great addition to that kit bashing workflow that we've been doing so far. Oh, and did I mention that action's a big thing in my filmmaking? So naturally, we had to have bigger explosions, and this time we use Unreal Engine's Niagara system to allow us to have better control on the way the particles look for things like explosions and smoke to give them more of a volumetric feel than we had before. We also utilise physics with debris from the explosion too, again all in real time with Niagara's control system, which Andrea actually set up in a way that allowed me to have control to tweak the parameters as I see fit by adjusting the values and sliders. Now we have to remember guys, that this is all final pixels, meaning there's no compositing done on any of these shots. Now Unreal Engine's 4.25 improved the way we render out the final pixel shots, and instead of capturing them like we did in Battlesuits, we now had a dedicated movie pipeline renderer that allows us to just not only batch queue render all of my shots, which is a really great feature, but it also allows us to render out EXRs, high resolution formats like 4K and more, and crank up the anti-aliasing and samples to allow for a more crisp cinematic final pixel render. So I guess that's the end of my presentation, and I'm hoping that I've inspired somehow, or you guys have taken nuggets of information that would be inspiration for you guys and motivate you guys to go off and make your own content. Because here's the thing, you know, like I've mentioned throughout this presentation, we're in a really interesting time. You know, this is real-time technology in the grasp of our hands, and it's free to download. You can download Unreal Engine for free. You could pretty much do all the stuff you have at home. You can start making really cool content, and that's very exciting. You know, as you saw in my presentation, I'm very hands-on in all of the aspects. You know, I'm animating cameras and so on. You know, that's all education that I learned just by watching YouTube and the tutorials and just trying things out. So not only am I excited from a filmmaker's point of view of the, you know, the fact that I can tell these stories and in a democratized animation way, but most importantly, other filmmakers out there now that were quite afraid to do animation can now look at Unreal Engine, look at the tech and say, hey, you know, we could do this too. So I'm excited about the new stories that are going to be coming out, the new brave and bold ideas that were usually pretty crazy to read on the script and pretty much unfilmable. You can now do it using Unreal Engine, using real-time animation to create this cinematic level quality of content.
Thanks, Alex, for that really interesting talk. I really loved the section on the accidental camera transitions. I thought that's just so compelling to find new camera angles. I have a specific question on real-time ray tracing, and you really highlight the importance of the subtle effect that it's providing, especially for real-time virtual production. It's something that you wouldn't get otherwise from, you know, massive post-production rendering. How much of an impact has that produced and on the reception of your productions?
Yeah, you know, it's an interesting question, Nigel, because I remember when I first dived into Unreal Engine, you know, the first thing I did was turn on ray tracing, cranked up all the settings as high as I can to see how far you can go. And then, you know, the more projects you start to do in Unreal Engine, the more productions you do, commercial productions, as well as R&D. But mainly for the production, the actual commercial ones, you start to realize that you try to optimize as much as possible. So like when dealing with ray tracing in the animation productions that we do at my company, we kind of have to wear two hats. We kind of wear a filmmaking hat, which is telling the story. And then there's the other hat, it's kind of like a game developer's hat, where we're constantly optimizing because we need to get renders out. We need to show dailies. We need to show executives and actors and so on. So when it comes to ray tracing, you know, for me, I start to ask two questions. Firstly, do we need it in the scene based on what the camera is doing and aesthetically? But secondly, does it serve the story? You know, one of the reasons I highlighted the idea of using a puddle, because, you know, we built this great environment with puddles, but, you know, as I was animating the scenes, I start to realize that I'm not really seeing the puddles. I'm not really seeing much reflections, yet I'm having to like utilize my GPU power a lot when I should be allocating that GPU power for things like the explosions and the particles or the GPU driven particles, you know, and so you start to have that battle. So, you know, we start using ray tracing, you know, through most of our production because it looks really cool, looks really nice. But currently we're on an anime, hence the poster of Akira in the back. You know, we're doing an anime at the moment, and we start to realize the more you stylize your projects, the more you start to realize, do you need ray tracing or not? So far for the anime, we've kept RTX on, but in terms of the post-processing side, we've actually haven't need to like crank up things like the GI and the ambient occlusion and reflections. We've kind of used kind of standard reflections, mainly because, you know, we don't need it. And it's quicker. It's, you know, it's stylized anime, right? But there are moments when there is an equivalent of a water puzzle. In our case, we're looking at glass. You know, we will then, because we have RTX checked on, we can go to post-processing for that specific shot in the sequencer. We tick on RTX just for that shot. So, you know, it really is down to the aesthetic, but also down to like what you need ray tracing on. You know, I wouldn't want to do the mistake I did with my first production, Battlesuit, where you have ray tracing for everything. And you're like, why is this taking forever to like crank out these? Or why can't I move around my shots? Or more importantly, you know, when you're working with a team and and then your animator is trying to block a shot out and they can't move around the viewport. They're like, dude, like you got, you know, RTX ticked on in this whole scene that we can't move around. So, you know, as a filmmaker and also as part of the team, everyone starts to wear that hat, like, do we need RTX? And it's kind of controversial because obviously there's a lot of video games out there that are, you know, pushing RTX, and a similar thing with our productions. That, you know, the conversation we have, you know, with my TD Ronan or my artist, Andrea's like, do we need RTX? Now Andrea's like, we should totally have RTX. I want to have all these lovely specular highlights, all these puddles and so on. Whereas there's Ronan's like, well, you know, you're kind of grinding the scene here, you know, like HaZ can't move around in the camera, especially when you're using a virtual camera as well. Like, you know, unlike Callum's, what they're doing with tethering, I'm doing wireless because I'm in my front room moving around. So, you know, if you got RTX on it, doesn't really help that much. So it really is, like, to answer your question, it really is down to the aesthetic. And I think you'll find, you know, one of the things is more projects get pushed through in Unreal in terms of like final pixel. That's the thing, we're doing final pixel. We're not doing any compositing. Feels like I've gone to the dark side here because I used to be a compositor. But like, you know, we're doing final pixels. You know, we start to realize, like, you know, the more stylistic you can make your project, the less it becomes like a video game cinematic, which is why we've gone for CG anime for this project we're doing currently, because we want to create an aesthetic that isn't being compared to video games cinematic, but at the same time, we're trying to combat the speed and latency issues that we'll get.
That's really interesting, especially that you're looking at using CG and anime, especially now that Studio Ghibli are doing a full production in CG. Right. And I really think that hopefully it'll drive forward as well. Like other animes will use things like ocean rendering and superimpose that on the traditional methods for production of animation. I'm really excited to see your production. Do you have any comments about any challenges that you face with that? Particularly, are you doing pure CG or are you trying to do a composited style between traditional drawings?
Yeah, absolutely. No, it's all CG. We spent a lot of time building the shaders. A lot of it is the shaders. When we did our R&D, we originally used post-processing, to create that kind of like that cell shaded look. And we found that, as with anime, I'm going to sound like an anime nerd now, but yeah, it's all about the hard lines in the hard. And the thing we found with the post-processing method, the further you pull back, those lines get thicker and thicker, which is not what it's supposed to do. So we realized a lot of the work has to be put in the actual shaders itself. And it's great. It's nice because I don't have to worry about having perfect articulated face. You really, and I'm referencing the 90s anime here. I'm not referencing sort of like the Ghost in the Shell on Netflix. I'm referencing Ghost in the Shell back in 95, where it really is about the flat shaded look, but having that high concept storytelling, world building, which Unreal Engine and any real-time engine does so well for the filmmaker. But also in terms of the animation, you just get your basic animation, and a lot of it's the expressions. So I spend a lot of time getting the perfect expressions and then kind of motion mixing between those expressions in sequencer. And that's been like a whole new way of making films. But the little kid inside me who grew up watching manga and anime, for me, it's amazing that I'm able to do that in a real-time environment and not having to do cell shaded drawings like they did back in the day.
Thanks so much for that inspiring talk. I really enjoyed it. And I'm glad that you're pushing ray tracing technology for real time.
Definitely.
Especially virtual production. Thanks again. So the next talk is going to be by Jeff Kember from NVIDIA. He's the Director of Developer Relations, and he's going to be talking about the Omniverse virtual production pipeline and how it's being used today for virtual production for kind of connecting all the different services between engines, modeling tools, and the actual rendering hardware technology. So please welcome Jeff Kember.
Great, thank you, Nigel. Happy to be here this afternoon and this morning, depending where you are in the world. I have a presentation to share with you today. So here to talk with you today a little bit about the virtual production side of Omniverse. So one of the problems that we're finding that needs solving is this one-to-many problem. The idea here is that you have a file that you want to export, and it becomes incredibly challenging to manage all of the different versions that you might have. It becomes a one-to-many problem here. You have an FBX and Lembeck, you have file naming issues and so on. So what happens across all of the different independent software vendors, the digital content creation packages you're using? What happens if you had the ability to just have a real-time collaborative environment where you could export effectively a file one time and then have a real-time session across that? One of the technologies that we developed a few years ago based on UE4 is the NVIDIA holodeck. And the cool thing with this is it allowed for multiple people to be able to join into an environment. And in this case, look at this impossibly expensive car, but have a design conversation around it and an engineering conversation. Not only the color, but the form, the shape, the construct, the mechanical engineering around how it works, but at the same time, be able to get together and just look at it, have this head-mounted display environment that existed across disparate locations. Now, some of the challenges for us are the fact that this is a rasterizing engine, and there was some decimation required in preparation, in order to be able to get this model in. But at the same time, there were some incredible tools that were built. I mean, who doesn't like the cutaway here in terms of being able to see the engine structure and suspension construct of this car, and of course the ability to blow up the car effectively and have a look at it. So there was a desire to be able to scale this and say, what happens if we wanted to be able to simulate something at a really, really large scale, like the entire product line from a large car company, or if we wanted to be able to effectively put this car into a city, and what does that look like? And then how do we deal with hundreds of thousands or millions of lights and hundreds of thousands of cars and so on? So there was a desire to build some multi-GPU scalable architecture beyond this. And that really essentially became the underpinnings for Omniverse. The idea here is that we have top industry tools on the left-hand side here of this slide with real-time collaboration, but most importantly, it's built on open standards. So we have PhysX, which is open sourced from NVIDIA for our physics engine, and we have a significant amount of GPU acceleration built into the branch 5. USD, which is Pixar's universal scene description. We'll talk a little more about that in a moment. And then MDL for material definition language. So those are the effectively open standards that were built upon here. And of course, that's additive to Python and all of the other open source goodness that we have available to us. Now, I think a really important point here is the hydrodelicate system. So this allows any hydrodelicate compatible renderer to be able to be used with this system without restrictions. So you can use Pixar's RenderMan, Autodesk's Arnold, the Omniverse RTX reference renderer, which in itself is a new class of renderer. It has a real-time architecture as well as a final frame level quality to it, and it scales across multiple GPUs, which again, we think is exciting. But this is a very important point in terms of built on open source and supporting the hydrodelicate system. So with Omniverse, you can effectively plug in whatever rendering technology you want and still use USD as the underpinnings. With USD,
hey Jeff, I just want to quickly interrupt.
Please.
Zoom is destroying the quality of your presentation. You might want to just disable your video, and I'm going to do the same to hopefully improve that.
No problem. I'll modify the settings I'm using. Just a moment.
No problem. I definitely want you to do your presentation to do it justice with
Sure,
the
no
visual.
problem. I understand. The problem I have is I have a combination of video and stills, so I'll show it in stills at this point.
Oh, cool. That's great.
How does that look, Nigel?
That looks much better.
Okay, there we go. I'll switch back and forth as needed then.
Cool.
So with USD, with tiny type, here we go. The idea here is that this is Pixar's universal scene description, and it's not NVIDIA's USD, it's Pixar's, and we contribute to it. We believe that this is a phenomenal way for you to be able to own your own data. This is open source, you own your data. Omniverse becomes an introspective visualization and manipulation capability on top of that. It supports layering. Multiple people can be touching various portions of the stack. There's metadata support. We do believe that USD is a worthy successor to Alembic, and then it will become the standard HTML of 3D virtual worlds. So if we think of Omniverse from a virtual production standpoint, an end-to-end solution here, and that's on the left-hand side, we have the ability to connect with a variety of content creation packages, from Unity to Unreal Engine 4 to Rhino to Substance Paint, and some of these can be universal scene description USD native, more so Substance Paint and Houdini, for instance. But the idea is that these are plugins that are maintained by NVIDIA and Omniverse. If you need source for them or have a special need, please let us know. We're highly collaborative in this environment. The Nucleus server, again, this is a super lightweight, difference-based engine that allows you to just update the bits that are changing. So if you change a brush stroke or if you change a model vert, only the changes get pushed. Kit is our collection of framework, effectively, that this whole thing is built on. It's all the open source goodness. There's some core services, and then on top of that, we have various experiences. And Create is one of those. So we effectively have Create for technical artists, and then we have View for the architecture, engineering, construction industry, and more coming in the future. For simulation, we have the ability to plug in our physics engine, as well as a variety of computational fluid dynamic, cloth solver, finite element analysis, and so on. But the idea here is that if you wish to do simulation work, this is a phenomenal SDK API platform to do it. And the real-time physics engine for virtual production is live and integrated in the scene at all times. So you just make an object rigid and it's live. And we think that's an important distinction. And of course, the RTX renderer, this is intended to be a reference renderer. The idea is that it's scalable across multiple GPUs in a single node, and in the future, multiple nodes. It's physically accurate and supports MDL. So really interesting architecture for this. In a standalone artist workstation, we have the ability to be incredibly latency insensitive for multiple artists to work together. The idea here, though, is that we created Marbles RTX as an example, and you can see the quality of the renderer here. These are just a couple of still frames from it. Now, there was a newer version of this created called Marbles at Night, and I'll just show you a really quick clip from that now. And Marbles at Night, and I am going to switch us back to video, honestly, for the next couple pieces, because I think we'll want to do that. Just a moment. And what we're looking at here is effectively the ability to have dynamic lighting non-baked. So imagine this being a virtual production set, and you could have, in this case, 400 lights, but you can have hundreds of thousands, if not millions of lights. So this is an implementation of a paper, effectively a many lights algorithm. And we went from having few lights to many. The idea here as well, because there's a physics engine running in real time, this isn't a distributed game engine or any kind. This is just Create running on the Kit framework and infrastructure. And there's effectively a very simple game loop that is just running that basically says, these are collision objects, and one of these spheres is a rigid body, and we're going to tilt the game board using a keyboard input. Again, I'm still excited about a roller controller. Watch this space. But the idea here is that that just runs in real time. Now, we're looking at MDL and lighting that is happening. Get simple spheres, some polygonization here, and it's just beautiful. So the physics engine is live. As we tilt the board and the environment here, this sphere is able to knock into other objects. You'll notice that it's fully ray traced. This is happening on a single Ampere GPU, and the physics engine's running on the same GPU. Now, you can put in multiple GPUs and path trace this. You can also have dedicated GPUs for supporting your physics acceleration. You'll notice that, again, that the lighting is fully dynamic, not baked. You could have RPGs flying through the scene, swinging chandeliers, the whole thing. The compelling thing for us, though, is that this provides a framework for real-time worlds, and you can add a tracked camera to this. You can have, you know, tracked hands and so on working through this to be able to manipulate the scene. You could reach in and grab these various objects that the spheres are colliding with and move them and guide them in real time. And again, all the lighting is fully dynamic. So we think this is a tremendous advancement in the capabilities for computer graphics. The idea here, again, we have this time-lapse shot of this Rube Goldberg environment. Everything, again, is simulated. The motion of all the objects and such, they're not keyframed. They're just driven by a single input, and then all of the various mechanical bits are real. And there, of course, are all the lights moving in real time. Now, I'll skip forward here to the magic of being able to have a virtual production deployment. So instead of just saying, okay, I have to make an application for a technical artist, the idea is you can use Omniverse Kit. And again, we may create off of this technology, but you can go through and modify a simple configuration file with a bit of Python. In this case, we have a film res asset that with a couple of sliders is going through, and in this case, walking along the surface. And we're anytime we have a foot in of penetration on the moon, we create a bounding box cube, which of course drives a displacement. But the idea here is that you don't have to build a framework that supports USD or real-time rendering. You don't have, file IO network, file handling, none of that. It's all handled for you, and you build on top of this open source goodness, and you can create an application that is as simple or complete as you want. It could have no interface except for a button that's on it, or again, anything you wish. So we think that's a really compelling opportunity to be able to deploy technologies on it without having to consume a expensive content creation license for a simplistic task. This is effectively the layout of how this works. Your virtual production on the left-hand side in terms of source packages, microservices.
Jeff, sorry to interrupt again. The quality, you might want to switch
is
back.
horrible. Yeah, this is the magic of Zoom, and so
I know, isn't it? It's terrible.
Well, it's optimized for one or the other. So, from a simple virtual production standpoint, I'll stay on these two videos. The idea here is that we have effectively, we know this is a bipedal engineer, and we've gone and done a IK solve in real time on the GPU, and we're driving a simple character. So although it's a film res asset on the right-hand side, we're able to render it in real time. And the idea here is that this is to replace, I have a simple camera, and I'm just going to look at a recording of myself. Instead, this is, I'm going to drive this dinosaur or whatever creature it is you're driving. Now, someone can step in with a 6-DoF camera in the case of a tablet or a high-quality tracked camera, or even an iPhone or Google Pixel device, an Android or Samsung, on a DJI stabilizer and so on. All of that can be tracked and work. You'll notice there's also an artist on changing the position of the flag in real time. These people don't need to be in the same location. So this is a low-end virtual production solution. And by low-end, I mean it's happening on equipment that you have effectively in your room with you right now. The higher-end virtual production solution here is multiple individuals located in different places. So we're using Motion Builder, Mobu, and we have Kevin on the right-hand side, who's in an Accent suit, and that's driving a nice 200 hertz update. And so we have high-quality sampling, but that's also being pushed out. Lou is over in a similar suit in St. Louis, so these are more than 40 milliseconds away. And then we have a virtual camera, which again can be any scale of camera from a tablet right on up to a Red or beyond. And the idea here is that these individuals are having their data feeds pushed across the public internet with no magic traffic shaping or quality of service. It's just there's a VPN overhead, there's Wi-Fi, but the point is, look at the scale of the room that they're in. They're just running around, and any drop packets over the public internet don't care, because we have the 200 hertz high quality Motion Builder sample that we can resample. Now we're looking at this in real time. All of the packets are arriving in Santa Clara, and we're rendering this on just a simple GPU. You can then, of course, re-render this on high quality, 8 or 16 or multi GPUs. You can also add either Cloud XR technology to stream the performer's viewpoint directly back into their headset, or use something like UE4 to be able to provide a high frame rate, 120 FPS virtual experience for the actor, so they can actually get these Pratt hits and make them land. And my point is that you could provide that to them in a little backpack so they can see what they're doing. And then in addition, go through and sample the data later at super high quality and be able to have a high quality offline renderer, which happens in seconds of frame. I'll stop there because that's the end of my time today. Please get in touch with us. We have open beta access for this coming shortly. And you can also sign up for early access at NVIDIA. There's a tremendous opportunity to play with Unity and UE4 virtual production, as well as have a multi-GPU scalable framework, as you can see, that happens in real time. Nigel, I'm happy to answer any questions.
Thanks so much, Jeff, for the amazing talk. While we answer questions, do you want to just share your last slide through the presentation instead? The video quality dropped as well, sadly.
The horror.
And then we'll ask the questions and people can just actually see the amazing beauty that you're rendering.
No problem, I can do that.
This is perfect. So it's so amazing what you guys did, especially with the marbles demo. Like, we're going to be talking about that for years to come in the graphics community. The thing that I find quite compelling is how you're leveraging like both USD and specifically Hydra, the real-time viewport, for this work. And did you distribute the marbles demo as an executable because of that?
Not yet, but there's a strong interest in that. The original marbles demo took about 30 gigs because we threw some art production at it, and it ran on an RTX 8000. However, the team then went through and, as always, if you optimize something to keep a specific look, you can do it. So they got it down to 11, and then I believe ultimately 8. So I think it'll run, computation, it'll run on a 2070 Super, and I believe it'll run on 8 gigs now. So certainly on a 2080 Ti, and I've seen that in person. So in terms of the Turing architecture, that's great. And on the Ampere architecture, marbles at night, certainly will run on a 3090 and I'm assuming a 3080. But with that said, I think there's a strong interest in being able to get that out into the hands of the community. I would personally like to be in virtual production, running along Indiana Jones style behind giant spheres. So we'll see how we can make that go.
Well, that sounds really amazing, and that type of technology is definitely going to make that capable. Just want to check one thing. So,
do you have any questions in our feed this morning, Nigel?
No, I don't have anything up yet. Usually the questions usually come as soon as the presentation ends.
Okay, awesome.
It tends to be the case. I do have one follow-up question for you.
Please.
With regards to the motion capture and the rigging. Yes. So particularly for ray tracing, how important is it to, when you're doing the skinning and when you're deforming the model for a scene like this, how important is it to actually have a correct deformations, especially for things that are specific to photorealism, like reflections or kind of transparent mediums or anything like that?
Well, so as someone who spent more years than I'd like to admit doing rigging and building corrective shapes and all sorts of horrible things that one had to do 20 plus years ago, I would certainly encourage all rigging and deformations and again corrective shapes to be kind of the best you can be in terms. Treat the RTX renderer as a really fast offline renderer conceptually from a quality standpoint, because it's a ray tracer and a path tracer. If it'll fit in the GPU, we can render it. You don't have a penalty for having millions of polygons in the scene. So being able to have a hero asset that's film quality and beyond in terms of it can survive an extreme close-up. You could literally say, oh my gosh, there's a micrometeorite just went through the shoulder of this Apollo astronaut spacesuit, and we have this. We want to show the micro tear and this incredible cloth that they have and little particles flipping out. I mean, you could literally have that level of resolution on those details around the shoulder and just carry that around with you as production weight effectively on this hero suit. You could have it close up for that shot, but you could also carry it around for the whole scene if you felt so inclined. But the idea is it gives the director that incredible flexibility to really do what they want and get right in close on things. And that's the magic of this ray tracing, path tracing engine, is that it will provide that highest level of visual and physics fidelity from a look standpoint, but at the same time allow you to get right in and really observe the mechanism. So in this case, yes, I would make sure that the corrective suits and interpenetrations are sorted. We're not running a live sim on these suits, so you can see some interpenetration with the arms and so on. That was more a function of just how much time we had to build and rig the scene. But with some additional polish, yes, you would certainly have, you'd certainly protect against interpenetrations and make sure you had the best corrective shapes on shoulders you could.
Thanks so much for that amazing answer to my question. So that's all the time we have. And I just want to thank you again, Jeff, for the incredible talk that you've given us. I can't wait to see what people create leveraging the Omniverse for virtual production.
Absolutely, you're welcome. I'm really excited to be here. Thank you, Nigel. Thank you for the opportunity. I'd like to encourage everyone to head over to the Omniverse page at NVIDIA for more information, as well as to sign up for early access and then watch the space for our open beta access. Thank you so much for having me today. Really excited to be here.
Thanks again, Jeff. And for everybody else, please go on to Discord and go into the networking section for virtual production, and I can try and field some more questions there.